So I got all the raw stock chopped up. They're about 9 1/4 each. The overall length of the blade is about 9 inches, but cut it to about 9 1/4, so you got a little bit of extra on both sides, so you don't end up too short. These are the two fixtures I use. First operation, we'll put the RWL34 in the vise and drill our mounting holes, which are these here. They're used with, so these are 3/16 shoulder screws. They're threaded on the bottom. They're an 832 thread on the bottom, and then that shoulder is a 3/16. And then I'm going to take a 3/16 drill bit and drill those holes into this piece of steel in the first operation, and then second operation will be the bevel. What I'm doing to locate my part every single time is, this is a combination square, not combination square, it's an adjustable square, and this is set up so that every time it can be repeatable, so that say this part gets drilled, I can take it out, grab my next part, put it in, and now I'm doing it one-handed. Now I lock it down. Now it's in the exact same place, and I don't have to reset my zeros. It's gonna be, what's this one look like? Nope, it's an old one. 2.2. Yeah, that looks like our first operation, so we're gonna go ahead and accept that. We need tool number 55, which is a 3/16 drill. We're gonna go ahead and post. Great. Now the G-code's been generated. I need to go ahead and set up tooling, and then we'll go from there. So right now I'm setting my my depths for all my tools, my tool heights, because the machine has to know exactly the height at where your tool's at. So this particular tool is number tool 55, so I'm going to go scroll down, find tool number 55. So height for tool number 55. Right now, originally what you saw me do is I set my Z reference. You know, I got a reference off something, so I set this as my Z reference. Now I'm going to set this as my height for 0. So what I'm going to click F2. I'm going to measure for tool H55, and now we got our new Z height. So now we're going to go ahead and save, and now we're ready to do the first operation. So after the drill operation, really kind of any operation, you're left with a burr, you know, on every single hole. You got, and it's on both sides, and so on every single piece, each one is a countersink. Each one has to be deburred. On both sides. Yep. So there's 7 holes times 2 times 12, because there's 12 knives. It's a big stack of knives right there. It's crazy how heavy this is before you know, I mill all the weight away, but it's heavy. Got a lot of weight to it. I think I'm doing this 12. Yeah, 4, 8, 12. Yeah. Alright, so on to Operation 2. Op 2? Yeah. Op 2. We're going to be doing the bevels next. Yep, so this is our... come on, faster than that, please. There we go. So this is the bevel fixture that I was showing earlier. It's got that slight taper. This little mark here so that I know that that's 0, and that goes up in that corner, because, you know, somebody comes along, they put it in that way, thing's going to be absolutely back-asswards. So we know that that's going to be 0, but first I need to clean all that chips out, because things aren't sitting very flat. In machining, you got to make sure everything's absolutely dead perfect. You know, one little tiny hair, one little teeny tiny chip that puts, you know, this little corner up cattywampus will just absolutely, you know, destroy stuff, and you'll get crazy outcomes from just little tiny mistakes like that. So in machining, you got to make sure everything's absolutely set up perfect, and you got to make sure everything's the machine knows where everything's at. You know, because you can cause a lot of damage if you start running, you know, the spindle into stuff. And all right, so to get ready for the next operation, I've got to put in the new bevel fixture and get it zeroed up, and then I've also got to put in my new tooling and get the height offsets set so that the machine knows where everything's at, and it can run the program and everything will run fine. So basically what I've got, you know, tool holders here, and I've got to put my new tools in the new holders and then tell it what the height is for those particular tools. So the way that I programmed this was so that the highest part of the fixture, which is this side, because this is a taper, is where my Z0 sits. And then in my program, I do all the math and calculate how high the first piece is going to be. So what's going to happen is, you know, so this is, I've got all my holes. These are my locating holes. These 4 right here. I'm going to mount it to this fixture using my pins, and then the machine's going to come in and cut it flat. But because the blade is at the angle that I want my bevels to be, it's going to give us the perfect bevels. And then all I had to do was figure out the correct height so that the piece where the actual edge of the blade is has the right thickness for heat treat, because you can't bring that down to a 0 or else it's not going to be strong enough for heat treat. So you got to leave a little bit of a thickness on the actual edge where the blade's going to be. And that took a little bit of tweaking, and I've got it all figured out now, so that the program should run great. But as machining goes, sometimes that doesn't happen.
I can't get it, got me so cold, and I don't know to take a trail in the world. I can love you, yeah, I'm gonna love you. I'll give you all of what I've got, the fancy things, baby, I have not. Just gonna love you, yeah, I'm gonna love you. I'm gonna love you, baby, cross my heart and hope to die. cross my heart and hope to die.
Alright, so it's been about a day or two for me. I just got off work. I worked like 12 hours today plus drive time. It's like 9:30 at night. And yeah, it's about 9 o'clock. Worked 12 hours today. I'm also working. It's Friday. Also working in the morning. Got a bunch of stuff to do tomorrow. But I'm here after a 12-hour day in the shop. 9 o'clock at night. Gotta get some stuff done. So I'm gonna pick up where I left off. I haven't been looking at the camera the whole time. I'm gonna do this twice.
Okay, so I've got 8 blades that are... Ooh, don't fall over. I've got 8 blades that the bevels all need to be cut on. These ones are all finished off the machine. But I was just doing a test run, make sure all my code works, did any of the programming that I needed to do, and make sure they're all dialed in before I, do batch work and do all 12 of them, and then end up making a gigantic mistake and, ruining $300 in steel. So those ones are good to go. I'm gonna go ahead and put in this fixture, and I'm gonna explain, what I'm doing and why, and how it is that I zero everything in, so that the machine knows where the part is, the fixture is in space. Because I can literally take this part. This is my fixture, and this is my piece of steel that gets bolted to it. At a very accurate and very measurable. It's a very accurate and very measurable, consistent application. So what's going to happen is this adjustable square is what I'm using to keep my zeros, basically my X and Y zeros, perfect. So like I can put this here, I can put it up here, I can put this here, I can I can mount it here if I wanted to, but how is it that the machine, the mill, knows where my part is? Because I have to tell it exactly everything that I want it to do. Every single tool path you see, every single movement of the machine that you see, I program in AutoCAD. Every single tool path, I program. So if you look at this, you can see the individual lines from each tool path, and every single one of those lines is drawn by me in AutoCAD and then converted to G-code in this program. So every single thing is completely programmed by me. I don't just, give the computer, an idea and it makes it happen. Every little tiny detail is programmed by me, and that's why, even if I'm off by one zero, it could make a world of difference. One of the prototypes I did, I added one extra zero, and it made it turned a measurement into 50 thousandths rather than 5 thousandths, which is just insane. It's a huge number. It's a huge difference, and it just creates totally different outcomes. And that can get, scary because, this is a very expensive machine. If I tell it to do something, it could completely drive the spindle right into the vise and, cause thousands of dollars of damage. So you got to be really careful. But it's fun. I love doing it, So that's why I'm here. So my tools for this, I'm cutting out the shape. Ooh, I'm about ready for a new carbide piece here. This guy's getting a little dull. This is a 3/8 carbide, and then we finish with the bottle opener and some touch up with a 1/8 carbide.
Real bad. I've got a ton of gravel in my shoe, world on my shoulder, heart full of blues. I'm in the dirt,
for the record, this is the knife that I'm building. This is prototype number 4. This is made out of 01 tool steel, so it's not RWL. The RWL is a super strong steel. It's imported from Sweden. It's hardened to 62 Rockwell. Holds an edge like crazy. 01 tool steel is just a little bit more of a beginner steel. Easier to work with, easier to heat treat, a lot more forgiving, a lot cheaper. So this is what I did all my prototypes with. But this is the exact same shape, and also this has the black oxide finish on it. It hasn't really turned out for the RWL. I don't know if you can do a black oxide finish for cold bluing. This is the product, and it just turns this thing black. So I don't know if I'll be able to offer that with the RWL 34, but it looks really good. This handle G10's also been sandblasted, so oh, my hands are dirty. So it gives it a real grippy textured feel. Bottle opener, the bottle opener works great. Window breaker. It's a real aggressive and forward-looking knife. Very, kind of sharp angles give it kind of a real aggressive look, which I like. And then the jimping, which we'll be machining here soon, it just absolutely grips your thumb. Your thumb just stops, but it doesn't bite into your thumb, so it's great. It works really well. This doesn't have an edge on it. Just a prototype. So off the off the machine, getting the tool's super. It's wore out. It's dull, so that's why it's leaving this super rough burr. I'll just hand sand all that off. I just changed the tool, the 3/8 carbide. I just changed the tool to a nice new one. So I'll show you what it looks like when I change that sharp tool. It's night and day. Yeah, this looks much better straight off the machine. Also, this rust is from the coolant. It's a water-based coolant, so the rust doesn't come from the knife. The knife's stainless. It pretty much shouldn't rust. It's all coming from the coolant left on the metal. Alright guys, I'm going to go ahead and end the video there. I'm going to go ahead and do the other 6 off camera. I really hope you learned something. Be sure to subscribe, like, and share. It really helps me out. If you have anybody that you think might like the video, go ahead and let them know. I'm going to be trying to do these pretty frequently, and then keeping people updated of what I have going on, and trying to teach them things. And I hope you enjoyed. Thanks for watching.